I don't think anyone has joined, so let's wait. Okay, people are joining in now.
Hi, Bomik.
Hi, Abhay. Hi, Rohi. Hi, Rahul. I think Saransh is joining in as well. So give him 1 minute, then we can start. I hope you can see the
Okay.
screen, right?
Yes.
Okay, fine. I think Saransh has joined in as well. So let's start. So until yesterday, we have looked into some very basic operations with NumPy, and we did a quick revision at the beginning of the class as well. So now we will continue with the rest of the matrix related operations, which we can do using the NumPy library, especially on arrays, because this is what will be mostly used when we do the data science part of things. So just to save time, what I've done is in this notebook, which I'm going to share after the class. This notebook is already executed. So I've executed all the cells so that I can explain swiftly, and then I can go ahead. So starting first, I have imported the library, and then I'm going to do some operations which are otherwise known as element-wise operations. So if I'm going to create an array of 4 elements or 5 elements, uh, on top of them, I can do some basic operations, and I can do some on the top mathematical operations as well. So we are going to look what operations are actually permissible and how we can do this. Okay, so for example, if I would like to have a scalar array created, or a one-dimensional array, which is having 4 numbers, 1, 2, 3, and 4, and then I would like to add some number to it. So a plus 1 in this case is simply going to result into a, and each and every element of a being added with 1. Okay, so a plus 1 does not mean that I'm adding 1 as an item one more time. Okay, so it is an addition. So as simple as this, we can do the addition of any array which is created into NumPy. We don't need to create any for loops or any kind of looping structure so that we can go through each and every item and then we add something. Now this is what was not possible in case of, let's say, lists or any other inbuilt structures which we have already seen in Python, right? The same thing applies with any such kind of basic mathematical operations. Example given here, I've taken only 2 examples, but this is equally applicable for all the kinds of basic math operations that we know about: plus, minus, sum, plus, minus, then it will be divide, then it will be multiply, and then the power or the exponent sign. So in this case, I'm taking the exponentiation. So I am doing a to the power 2. Power in case of Python is represented as 2 stars. So if I do a 2 stars 2, then each and every element which is part of this array a is actually multiplied, or is actually multiplied by itself. So it is squared. So 1, 2, 3, 4 becomes 1, 4, 9, and 16. Okay. Then we can also do element-wise operations for more than one array. So what we are doing over here is, let's say I have already created an array A, and then I'm creating an array B. Okay. So what this array is, I'm going to do some code writing here because I want you to know what this is doing over here. So that's why I've just added 2 print statements. One is B and the other one is A minus B. So B is what? B is an array which I'm creating of ones. Okay, so I'm creating an array with ones and then I'm adding one. So if I am going to do only the print of B, then it is going to tell me that it has created an array consisting of ones. Okay, so it was an array which had only one. So if I write something like this, it has 4 elements with each element being one, right? I've not defined any dimensions here, so that is the reason why. So that is the reason why it is not showing any further rows and columns, because it is a 1D. It is kind of a scalar, you can say. It is a one-dimensional array, so it has created 4 items because I have entered 4 over here. After that, what I'm doing in this creation step itself, I'm adding 1 to it, and that makes it 2 2 2 2. By default, you will actually notice that these are actually decimals, so these are represented as the decimals. So we can change that using this thing, which we have already seen in the first class. We can use an option called D type, and we can enter the type of number that we would like inside there. It can be 64-bit integer or a 32-bit integer. To normal eye, it seems the same. In the background, the way it is mathematically calculated or the binary representation is going to be the different one. Now, if I print B, I can see that I have created an array B, which was initially a NumPy array of ones with size 4. It is a 1D array, and then I've added 1. If I do A minus B, I can still do that, and I can actually print the output. In this case, I'm doing operations on more than one array. Okay. Now what I'm going to do is I'm going to introduce a problem, and that problem will be I am going to not do A minus B. I'm going to define C, and I'm going to say np.array. Okay, similar to A, right? Similar to A, I'm creating another array which is C. Okay, this is just for the demo purpose. And in this array, I'm actually putting a dimension of equal to 2. So there are only 2 elements in this array. Then I'm going to print this array. Okay, so I can see that I've created an array which has 2 elements, 4 and 5. Okay. In this case, note when I'm creating an array with array function, I don't have to specifically determine the D type. By default, it recognizes the data type. Now, what happens if I do C minus B? Okay, it is going to give me an error, right? It is going to give me an error because in a single dimensional array, if I'm doing any operation on 2 single dimensional arrays or n dimensional array, the n of the first array should match with the n of the other array. In this case, the n of A was 4, the n of B was 4, hence I was able to do A minus B, resulting in an array which is this. But in the second case, I have an array C where n is equal to 2, and I'm trying to subtract B from it where n is equal to 4. So it is not able to do that, and it gives me an error. Operands could not broadcast together because one has a shape of 2, which is C, and the other has a shape of 4, which is B, right? So this is something that you need to remember while doing the operations. You cannot do any mathematical operations, especially plus and minus, okay? You can do others, and we are going to come to them. You can do matrix multiplication and things of that sort if you have different dimensions of array. But when it comes to this kind of arrays where uh, you have simple operations like plus and minus, you cannot do that because these are scalar operations, and they can only be done if you have the items of the same size. Okay, they have to be of the same size. It doesn't matter whether they're 1D or they are ND. Okay, but the n of A and B or B and C has to be the same if I want to do some operations with these, right? Now, the same applies for A into B, or it is going to be different. So let's see what is happening here. So A multiplied by B is something which is quite simple to understand. I'm just multiplying each and every element of A and B. So how that is happening is, this is B, and what is A? I'll have to print A and B once more so that I can see what is A and B. So I'll print A, I'll do print of B, and then I'm going to do A multiplied by B. So it is clear that it is doing a item by item kind of a multiplication. So 0 multiplied by 2 is 0, 1 multiplied by 2 is 2, 2 multiplied by 2 is 4, 3 multiplied by 2 is 6. Okay, so this is how it is going to go. Now what happens if I am going to print C? I can see that C is not of the same size. Okay, can I do B multiplied by C? The answer is no. I cannot do B multiplied by C, and there is a particular reason behind it. Okay, let me quickly explain the reason. We will be looking into this reason in far more depth when we do a review of matrix algebra. But I just wanted to quickly tell you why this is not working. Example given, I have two matrices. Okay, I'm just trying to draw. I have two matrices. This one has one row, right? It can have any number of, let's say, it is having only one column, C1, and it can have any number of rows. Okay, and then I want to multiply that with another matrix where I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, is this operation going to work? So, mathematically speaking, what I need to do in this case is I have to multiply each and every of these elements and plus them up. So that's what we do. Okay, but in this case, it's not going to work. The reason why it is not going to work is because the row of the first matrix or the number of rows of the first matrix should be the same as the number of columns of the second matrix. So this matrix has a dimension of 4, 1, right? And this matrix has a dimension of 3, 3. You cannot do a multiplication of two matrices where the dimensions are 4, 1 and 3, 3 because row into column and row into column is the dimension. So this value has to match with this, or the row of a particular matrix has to match with the column of the particular matrix that I'm trying to multiply with. So there must be some kind of a commonality. Had it been the case that I had 4 columns over here, then I had a probability that it would have tried to multiply, but then also there will be an error because I need to match these two things. Okay, the commonality must exist over here. So these are things which we will be reviewing later on, but this is the reason why we are getting such kind of error. So please don't be under this impression that all the operations are or can be performed. These are the basic operations which are entirely governed by all the rules which is there into matrix algebra. So when we look into that area, it will be more clear. Okay, give me 1 minute. Fine. So let me just delete all of this and clear. Fine. Then we will move on with something else. So what we are going to do now, we are going to do a multiplication. Now, as I said, I can do multiplications of similar sized items, right? So if I do this, what I'm doing exactly over here is that, let me print C as well. So I'm creating a diagonal matrix C using the diag function. In the diagonal of the matrix, I have 4 items, 1, 2, 3, and 4. Okay. Then I'm doing a C multiplied by C. Right. If I do a C multiplied by C, of course, just like A multiplied by B, which I have done over here, it is going to multiply each and every element. Okay. In this case also, the multiplication is going to happen in a certain fashion. So each and every element is going to be multiplied by the corresponding element. So row 0, column 0 will be multiplied with row 0, column 0 of the other matrix here, because they both are the same. So let me just print C once more, and then I'm going to simply print a blank line. So this one over here will be multiplied with 1, this 0 will be multiplied with 0, this 0 will be multiplied with 0, and so on. These operations are going to continue in the memory, like first of all the rows will be covered, then the second row, then the third row, then the fourth row. So these are row wise operations, these are not column wise. But irrespective of what it is doing, because these are two same sized kind of things, in this case a simple multiplication is going to occur, and 1 multiplied by 1, 2 multiplied by 2, 3 by 3, 4 by 4 is going to be my output. The reason why I'm showing this to you is because there are more than one ways of doing this. Okay, the other way of doing this is this. The other way of doing this is using the dot product. Okay, so what we are essentially doing in this case, or the matrix multiplication that we're doing over here, is otherwise known as a dot product of two matrices. Okay, in this case, A dot product is essentially dot by dot or item by item, you do the multiplication. Okay, as simple as that. You can use this as a kind of a conjecture to remember what is happening in case of a dot matrix. Okay, so essentially what is happening is the meaning of that dot can be simply represented, or let's say remembered, as each and every dot or each and every item which is there in the first matrix will be multiplied with the corresponding item in the next one, right? So this is what is happening exactly over here. There are two ways. One is to use a simple math kind of a thing, which is star. The other one is the mathematics way. So a mathematician will be preferring this, while a programmer will be preferring this. There is no difference between this one and this one. Okay, they are not going to be very different when it comes to the operations, but are they going to be different in terms of the performance? Let's see. Okay, I'm going to use a time it function. I hope I've written it correctly. Let me see what it is going to do. The cell body is empty. Time it is. Sorry. Yes. Okay. I'm just going to take a time. How much time it is actually going to take to do this C multiplied by C, and then I'm going to say time it for C dot of C. Okay. Let's see how much is the difference in time. Okay, so is there any difference between using a direct math or using a product? The answer, it seems in this case, is yes. Okay, there is some kind of a difference. Using dot increases the time, but this may will be ignored because it is not a very big kind of a difference. 500 compared to 900 nanoseconds, that too is not going to make much of a difference, right? The second kind of things that we can do are known as comparison operations. So these are, you can say these are actually mathematical, but in the sense they'll return you with a Boolean output. Okay, so what I'm doing over here is A and B. I have two matrices 1, 2, 3, 4, 5, 2, 2, 4. In this case, if I compare A and B, I'll simply write A is equal to B or no. So this is actually a question which I'm asking, which is being asked. Okay, so I'm actually asking, is A equal to B for each element of A matching with B, right? So in this case, what it is going to do, this operation tells the interpreter match 1 with 5. Is 1 equal to 5? Then the answer will be true, else false. Hence, this is the output. First is false, the second is true because 2 is equal to 2. Third is also false because 3 is not equal to 2. And then the fourth is also true because 4 is equal to 4. Right, so these are the element by element operations that we can do as simple as this. Okay, there are no functions. You do not need any functions because you have created them as arrays. Okay, you do not need any loops or anything. The same thing happens if I'm trying to ascertain if the items, each and every item by item, is for one matrix is greater than that of another array or another matrix, right? So in this case, the output is again going to be a Boolean output. Okay, now there is one more way in which I could do that. Okay, and that's, give me a moment. I think Rahul has dropped off. He's trying to rejoin. Yes, I've just added him back. Okay, so there is one more way in which at least the equal operations can be done. I'll leave it up to you to find out the rest of the comparison operations, which is really possible. You can go to numpy.org, and here is where you will find, sorry, I think I've given a wrong spelling. So it is numpy.org. Numpy.org is the website. You can go to numpy.org, or you can simply search for the internet. I believe my internet is just slow today. So you can go to numpy.org and you will be able to find that there is a documentation here. And from here, you will be able to figure out what all are the so here is the documentation link, the numpy.org/doc. So this is your documentation link from where you will be able to find what all are the other operations which are there. But if you are doing an array wise comparison and or an item by item array to array comparison, then this equal to may well be replaced with a function called dot array underscore equal. Okay, it is also going to do the same thing, but it is going to return only one value. Why does that return only one value? Okay, it returns one value if in this output you have more of a certain type than the other type, okay, or you have false is equal to true where the output will be false, right? Why I'm saying this is because, let's say, for an array which is A and for an array which is C, each and every element of A and each and every element of C is going to exactly match, right? So each and every positional element 1, 2, 3, and 4 is exactly the same as C, which is also 1, 2, 3, and 4. But in the case of B, there is at least one. There are more, but there is at least one element which is not matching with the specific positional element of A, right? In the case of B, there are two elements, right? That is the reason why if there is even one of the elements inside the array which does not match the same positional element of the other array, output of this array equal function is equal to false. Okay, so it's not going to give you element by element kind of a comparison which we saw when we did a simple math. It is going to tell you the overall outputs, a kind of a summary. Okay, the same happens here as well. If I do an array equal a comma C, why is it giving a false? Because maybe I have changed C. Okay, yeah. So this is now giving me the correct output. Okay. Now give me 1 minute. Okay. Okay. So we will continue. We will look into the logical operations now, and this is again going to be comparison. So you might wonder why we are doing a logical kind of a computation in a different ways, because this is not really going to be a comparison. So what we are going to do, this is, you can say, another representation of logically comparing each and every element of the arrays. So in this case, what is happening is, it is actually the same operations which is being done when I was doing the earlier kind of things, the earlier statements where I was using array equal or I was using the equal to sign. In that case also, it was actually doing almost the same thing, but in this case, it is doing a logical OR. Okay, so np.logical OR, I'll just quickly show you what this does. Okay, so this is a logical kind of an operation. If you remember in the college days, we had done the logic operations where each and every element inside the circuitry is going to be compared with the other. It is equivocally applicable onto binary operations as well. So what is done here is that it is to compare the truth value of x1 or x2 element wise. So x1 is the first array, x2 is the second array. Each and every element of x1 will be matched, or the truth value will be matched with the other one. Okay, so these are the binary converted comparison. So logical or any kind of logical operations is going to be a broadcast or an operation which is going to work on the binary representation and not on the value representation. So end of the day, it might well be the same as the output which we have seen earlier. But if we look at this example might be of help. If you do a true or false, then it is always giving a preference to true. Hence, the output for the first case is true. If there are two false, then it is giving me false. Okay, so maybe what we can do, we can take this example. We can take this example and we can create a new row. Let's enter this over here, and I'm going to enter all the combinations which we can have. So true, false, 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 true, comma, true. Okay, and then false, comma, true. Okay, if I execute this, why is this giving an error? Okay, sorry. There must only be two values, right? So sorry, extremely sorry. It takes only two arrays as we saw in the documentation, but I just missed that. Let me just put this back into two. Fine. So for the first one, what it is doing is, this is a very interesting kind of an output, right? So this output is being set by means of the operations that it has done. So false comma false is actually false. Everything else which has true contains the true value. So the representation of this should have been done like true, false, true, true, but it is doing it in the other way. So this true here belongs to this comparison. This false over here belongs to this comparison. This true over here belongs to this comparison. And this true over here belongs to this comparison. Okay, so any logical OR operations is going to check if there is at least one true positive, then the output is going to be true, else false. Okay, so that's what is happening here. Then what we are going to do, we are going to look into some transcendental functions. So transcendental functions are just a fancy name. This is just another fancy name of doing some mathematical operations. In this case, we are going to look into this, let's say, the sign of an array, okay, or the sign of a number. So we already know that there is a mathematical equation to find out the sign. Okay, you can also find out the cos. Then you divide sine and the cos, cosine, and then you get the tangent, right? So these are the same kind of operations that you can do with the arrays as well. So for example, what I am doing over here is, let's print A, and I can clearly see that it has 4 items, 0, 1, 2, 3, 4, and then I am actually printing out this. Let me also put this inside a print statement, and then it will be better to be represented. So the sign of 0 is equal to 0 0.0, sign of 1 is equal to this, sign of 2 is equal to this, sign of 3 is this, sign of 4 is this. Okay, so each and every element is computed with this function, and then it is resulted, right? So it is almost the same that we saw in case of addition as well. So in addition, if I do a plus 1, it's going to do an addition of each and every element, right? So if I do something like this, a plus 1, it's going to do an addition of each and every element. Similarly, the sign function is also going to do sign calculation of each and every element. Same applies for log. Okay, now this is something that I wanted to quickly show you about. I will be looking into these things into depth when we are going to do the data analysis part, but just because there is a small thing which is shown up on the screen, I wanted to quickly touch base on this. Okay, so this is a known problem with the IPython kernel or the Jupyter notebooks. So anything that it is getting as a warning, when it is trying to run anything and it is getting warning, it is always going to show the warning, irrespective of whether you need the warning or not. If there is an error, of course it is going to show you the error. If there is no error, it's going to show you the output. If there is a warning, it's always going to show that. And how you can handle that situation is that you can import a library called warnings, and you can say warnings dot filter warnings, and you just pass a value known as ignore. Okay, in this case, now it is not going to give me any warnings. Okay, it is just going to give me the output. Now whosoever is going to understand the output will be able to understand the fact that we have a minus inf over here because of a very simple reason. Let me tell you what is the reason. The reason is as simple as this. If I'm taking a log of 0, it is always infinity. Log of 1 is 0, and then the rest of the values. Okay, so logarithm of 0 is always infinity because it is like the division, right? So if I'm going to divide that, then a divide by 0 error is going to come. So that is the reason why uh, this is giving me an infinity. Then the same applies, or the same kind of operations can be done by means of exponential. So if I would like to calculate the exponential of each and every value, I can simply use a function like exp, and it is going to do that for me. Now, this we have already seen, so I'm not going to touch into this. I'll just take a quick pause because I believe we are already almost at the end of time. So maybe if anyone has any questions, you can let me know, or maybe we can continue. No, I think there are no questions. So let us continue. Okay, so now we will, I think we have only 10 minutes left. So we will look into some of the functions now, and then are going to continue tomorrow. Okay, so now what we are going to see is that something really very interesting over here. Okay, now np.array, I have created an array which is x. Okay, let me print this. I'm not going to do this operation right now. I'm going to do the operation at a later stage. Okay, so first of all, I'm creating an array X and then I'm simply printing it. So it is giving me a value 1, 2, 3, 4. These are the inputs I've given. What happens if I'm simply passing this array in a sum function? Okay, it is actually looping through each and every element and it is going to sum or give me the output of sum. In this case, or in case of a list, we have already seen that we would have created a for loop and then the for loop would have gone through each and every item, right? And then each and every item would have been summed and then we should have had an output variable which is going to return the sum, but that's not the case when it comes to NumPy. It is simply going to iterate through and that is exhaustive or it is explicit as well, I can say. So you don't have to mention that you need to go through or NumPy has to go through each and every item. By default, if you supply a function like sum, it is going to go through each and every item and give you the sum of all the items, right? You can increase the number of items as much as you want. It's going to work the same. Now, if I'm going to, or if I want to do some kind of arithmetical tasks which are related to not 1D array but 2D array. Okay, so for example, I would like to sum each and every element of a two-dimensional array. We have seen this with 1D array, but I would like to get the sum of 2D array. Okay, and in this case, sum does not mean that I have two arrays and I'm going to multiply them. Okay, what it means that I have a single array and I would like to multiply, or I would like to take the sum of the elements which are either in axis 0 or axis 1. So axis 0 represents two columns and axis 1 represents rows. So in this case, I have a 2D array 1, 1, 2, 2. Okay, so row by column I'm going. So 1, 1, 2, 2. So 1, 1 is in the first row, 2, 2 in the second row. Then I'm doing a sum where I'm specifically mentioning, please do a sum basis axis 0. Now, there is a difference between this call and the previous call. You see, in the previous call, I called the NumPy library and did a dot sum. In this case, I'm actually calling the object or the array, and then I'm doing a dot sum, right? If I'm doing an object call, then I have to specify the axis. If I do not do that, by default, an axis will be selected. Okay, let's see what this is going to do. This is actually giving me a sum. Okay, and what sum I don't know, right? This sum is actually the sum of all the elements if I look closely now. So if the output of this sum is equal to 6, I can clearly see I sum up all the items, this comes up to 6, right? If I would have done something like 1, 2, 3, 4, okay. Just a moment, I think I've done some mistake. Yes, sorry. I would have done this. Yeah. So if I had created an array which is 1, 2, 3, 4, then I would have taken a sum. Obviously, the answer would have been the same as the previous one. So np.sum, then you pass the value of x, or x.sum is doing the mathematically similar operation, but with the advantage, x.sum has an advantage of axis 0. Axis 0 means I'm only going to take the sum per column because I have given x is equal to 0 and return me with an array and not a single number. Okay, earlier one, if I do a control Z, if I just remove this and I execute this, I get a single number, which is sum of all the elements. If I'm doing an axis 0, it is giving me column by column output. Okay, but if I do an axis 1, it is going to give me row by row output. Okay, so sum of first row is 3, sum of second row is 7. So in the output, I have 3, 7. Here I have 4, 6 because sum of 1 and 3 is 4 and sum of 2 and 4 is 6, right? In the same way, I have other functions as well, which I can execute. The most common ones are min, max, argmin, and argmax. Min and max are easy to understand. I have some array and I would like to know what is the minimum value, what is the maximum value. This is a no-brainer. Argmin and argmax is actually the index of that element or the position where that element exists. So for min, it will be 0, of course, because it is the first element in the array, which is 1, and that is the minimum. Argmax is going to be 1 because on the first position in the array, this is 0, this is 1, and this is 2. On the first position, we have 3, which is the max value. Hence, it is giving me an output 1. These will be useful when we are going to look into the slicing operations into the array, right? So imagine you would like to slice out the values into a more efficient way, where you have a huge array with an n cross m kind of an array, where you have maybe a 20 cross 30 array. So in that case, these kind of functions are going to come handy. Okay. Now, I think we have 5 minutes. Okay, maybe we can cover this. Yes. Okay. So these are some of the logical operations that we are doing. Now, these operations will seem very weird at the first place, because first of all, you see, I'm calling functions like all or any, and then passing Boolean values. So this is my array that I'm passing, which is a Boolean value, and then what output I'm actually getting is equal to false. Now, why is this confusing is because this does not require me to create an array at the first place. I could have taken this out and I could have created a separate variable. But in case of logical operations, please remember, it is not mandatory that you should always have a defined array. Without even a defined array, in which case there is a variable which stores the values of all the elements of an array, that is not required mandatorily if you are going to do the logical operations. Okay, the same applies for any. What is the difference between all and any? All checks for all values being true. Any checks for even if one value is true, the output is true. So if I'm going to do this as equal to false, it is going to obviously tell me that it is false. Any other element, if it is true, then the output is going to be true. Now, I want to do a kind of a calculation which is on a big array. Okay, so I'm not going to do the calculations first. What I'm going to do, I'm going to print the array. Give me 1 minute. Yeah. So I'll just first create an array of zeros. So this is going to have 50 elements. So let's see how big is this. It is so big that it is not even printing it. Fine. So then what I'm going to do, I'm going to run a function which is np.any. Okay, and then I'm actually passing uh, a kind of a statement which will result into a Boolean output. Okay, so rather than passing a list or a list of values on an array of values which I already predefined or pre-calculated, in this case I have an array which has 50 cross 50, so it has 2500 elements in place. It is not really possible for me to define each and every booleans, right? So in this case I'm simply defining a function. I would just like to know if there is even one value where a is not equal to 0. So if I go to the end and if I do this, then the answer is false. It is quite clear that it will be false. Why? Because this array is going to contain all the zeros, right? So all of the elements is going to be 0 only. So there is no element which is not equal to 0. So a not equal to 0 is always false. And because it is always false, the output is also always false, right? Now I can also do comparison operations inside the all function, where I may want to compare the same array with itself. Example given in this case, I'm comparing the values of a with a. I could have compared the value of a with b as well, right? And then I would have also done the calculations in this way, in which case it's going to compare each and every value. And because I'm using dot all, I'm not using dot any. Okay, if in this case also, I mean, all and any is going to result the same thing, right? But if I had different arrays, all is going to result into different output. Any is going to result into a different output. Okay, so that you can see over here. Okay, so what we are doing over here is, because this is all and I'm doing a comparison of this, a is less than or equal to b. Is a always less than or equal to b? The answer is yes. If you see, each and every element of a is always less than or equal to b, so the output of this part is true. What about the next part? Is b always less than or equal to c? Yes, b has elements which are always less than or equal to c. Okay, so that is the reason why it is doing an AND operation of true and true. So what will be the output if I am going to apply that on all? Because this part over here is actually returning a numpy array. Okay, and then I'm doing a dot all operation, and then it actually returns me the similar output, where if all the outputs are true, because this is true, hence the output is true, right? I think we will stop here. uh, we don't have time to continue. We have a time limit of 40 minutes. I think the time limit has crossed, so I'll just stop here. uh, I think we'll not have time to take any questions. Maybe if you have any questions, you can email back to me, and you can write on our chat group. I think that's okay with all. Then let's close the session.